Okay, we are live.
And now share that link. You are checking on your phone also, right? We are live. I'm not still able to see we are live.
I can see that we are live. I sent you the new link.
Yeah, okay.
I put it in a group also. In a moment.
Let's start at 10:40 so that more people can join. Let's start.
Yes, sir. So yeah. In the first problem, we are given a t test cases to solve. In each test case, we are given an integer n, and we are asked to find the number of ordered pairs of a comma b such that a equal to n minus b, and we are given the condition that a and b both have to be positive integers. So given these both conditions, because a and b are positive integers, like a plus b equal to n is just a line, and sorry, a and b are positive integers, and a plus b is just a line. So a can take values from 1 to n minus 1, while b can go from n minus 1 to 1. So this is the only possible values, because a plus b equal to n just lies on a line x plus y equal to n, and all the integral points that this is going to hit, which are in the first quadrant, is the solutions to this. So all those solutions should be of the form I comma a comma n minus a. So if both of them have to be positive, then the condition is like this goes from 1 to n minus 1, as this goes from n minus 1 to 1. So the number of possible values for a is like number of ordered pairs here has to be n minus 1 exactly. So for a given number n, just output n minus 1, and that is the solution to problem A. So now Vijay would go with problem B.
Is my screen visible?
Yeah.
Hello?
You can zoom a bit.
Yes, sir. Yes, sir. So this is the code for problem B. So in this question, sorry, one second. This is the code for problem B. So in this, what we have asked to do is, given a string consisting of any letters, any string of letters consisting of P, Q, and S, say P, Q, W, um, PPWQ, we have to convert it into its mirror image, such as uh, like we have to convert it how it would be seen as if we are seeing it from the through a mirror. So in this case, what happens is that if the first word is say P, the letter needs to be converted to Q, and this Q needs to be transported to the last. So this and W needs to stay as it is, and Q needs to be converted to P. So that is what I'm doing in here in the code. So initially I'm starting with, if it is a W, then I am keeping it as a W, and if it is P, then the letter needs to be converted to Q, and if it is Q, it needs to be converted to P. And after doing all this transformations, we also have to inverse the entire list. So to do that, I'm inversing the list, and then I'm just printing the answer. Now, for the question C, so in question C, what we are given is we are given four integers m, a, b, and c. So what m is? Firstly, there are two rows, each row containing m seeds, and in the first row, there are m seeds, and second row there are m seeds, and there are a students who want to sit. There are a students who wants to sit in the first row, and B students who want to sit in the second row, and C students who have no preference basically. C students have no preference. So in this case, what I'm doing is we want to find the maximum number of students who can be seated. So firstly, what I'm doing is I'm having initializing a variable answer to be 0 and leftover as 0. So first, if the number of students who want to sit in the first row itself, if that is greater than the maximum number of people who can be sat in the first row, that is n, the number of seats, Then select any M students out of the first A students and make them sit in the first row, and I have no leftover because I cannot make anyone else sit in the first row. And similarly, I do the same process for the second row. Now, if M is in case greater than A, then I make all the people who want to sit in the first row sit in the first row, and I also have some extra leftover seats. Now, I again do the same to the second row if that is the case. If M is again greater than B, I do the same process, and then I see how many seats are in total leftover. Now, if that is in turn lower than or equal to C, then I cannot make everybody who is leftovers to sit. I can only make the leftover number of students to sit, and I'm therefore increasing my answer by leftover. If in case leftover is greater than C, then I can make everybody sit. So answer plus equal to C, and I'm printing the answer as, and in the end, I'm printing the answer. Now to move on to D. So in this question, what we are given is we are given a list A, and like we have to give out another list B, which has such that say in the first case A is equal to 1 comma 2, and in the answer we are giving the answer as B as 1 comma 2. So the property that B should be satisfying is that Bi, that is in this case the element 1, must be the mode till A1 so on till AI. So in this case, B1 should be the mode of the sublist A1, and B2 should be the mode till sublist A1 and A2. Um, So to solve this question, so we are basically doing a constructive algorithm based question. So in this, like we are trying to make sure that each and every element occurs exactly once in the list B, so that um, any element that occurs in A will be the mode. Any element that has occurred so far in B will be the mode itself. Um, so in that, what we are doing is we are initially having an array that is visited, that whether that element has occurred or not, and the least element that has not occurred so far. Initially, the least element that has not occurred so far is one itself. So I'm initializing it to be one, and initially we have not visited any elements, so I have initialized everything to be false. Now I am iterating through a for loop of length n. If the now if the current AI is the mode that we want it to be. If AI is not been visited, that means if AI is not already present in B, then we visit AI and then append like the answer list is what is our final BI. So and we add it to the B or the answer list. Now, if the element AI has already been visited, then the element AI is already present once in the list, and we can add any other element that has not been previously added in the list answer to the list answer. Say the list answer is currently 1 2, and we want to add another element. We can add say 3. So if I mean assuming there are more elements, say you have comma 2. Now, like we can add any other element in here, say 3. Uh, so that is why I have this else loop. So while visited least, that is as far as every element so far has been visited, I'm incrementing least so as to find the least element that has not been visited, and I'm adding that element, and I'm changing the property of least in the visited array. Uh, and then in the end, I'm just printing the answer list, which is just the B list. Now for the E question, just a minute. I'll share my another screen just a second. So in the question E, is my screen visible?
Yes.
Huh. So in the question E, we are given five integers k, L1, L2, so L1, R1, L2, and R2. So they have given that x. There are two. We have to find the number of ordered pairs x comma y such that x varies between L1 and R1, and y varies between L2 and R2, and that exists a non-negative integer n such that y by x is equal to k to the power n. Now, uh, this this gives me an idea so that we can use some sort of graph way to solve the question, like in a solve it in a graphical manner. So they have given that x varies from L1 to R1. So what I'm doing is I'm drawing two lines. Um, X is equal to L1 and x is equal to R1. X is equal to R1 and x is equal to L1, and I'm drawing two another lines. Y is equal to L2 and y is equal to R2. Now they also want this condition that y by x is equal to k to the power n. Say k to the power n is equal to some constant c. Then all the solutions to the third point will be lying on a line y is equal to cx. That will be this black line, right? Which is denoting y is equal to cx. Now, and all the solutions of the first 2 points will be within this rectangular region formed by these four lines. Now, all the points that are the solutions will be on this line as well as in this region. So it will be basically these all the points that are within this line segment. And the number of points that are within these line segments can be found out by calculating what is the minimum x coordinate of this point, and what is the x coordinate of this point, and what is the x coordinate of this point, and subtracting them and like finding the difference between them. In this case it's 5 and 21, so that should be 21 minus 5 plus 1 integral points. So how do we find that points? So to find those points, so what we have done in here is I'm initializing the c to be 1 because n is initially to be n is initially 0, and I'm initializing an answer list so as to calculate all the answers possible. So whenever c is lower than or equal to r2, so first of all, when c is greater, say c is greater than r2, then we need y by x to be equal to c, right? And y is always lower than r2, and x is greater than or equal to 1. So in this case, we do not get any feasible solution. So the number of solutions after this point will be anyway 0. So I'm pruning my searches after that. Now I'm claiming my x-min to be L1, comma, ceiling of L2 by C. This is because in like, basically when the line y is equal to cx, and uh, this is basically because when the line y is equal to cx, and the lines x is equal to L1 or y is equal to L2, whichever like the minimum point x minimum will be the point where the line y is equal to cx and these two lines meet. And similarly for x max will be the point where the lines x is equal to r1 or y is equal to r2, which meets the line y is equal to cx, whichever meets it first. So in this way I'm finding x min and x max, and I'm consequently like checking if the solution is first of all possible, and if it is possible I'm just adding the number of solutions as found. Now, so as to explain why x min and x max are what I have taken, just so So for X-min and X-max, this so X-min is basically the maximum of like the maximum of these 2 points. This is because say I'm decrease say I'm increasing the value of L2. I say I'm like decreasing the value of L2, keeping it to be zero. In this case, the value of X-min would turn out to be 4, which is basically the intersection over here, and not the intersection over here, because this is basically where we basically want to find the maximum of this intersection, uh, so as to find the number of points where the solutions are possible. In the same way, out of these 2 points where the line intersects y is equal to cx, we want to find the least one so as to find the number of points that are within the line as well as within the rectangular region. And yeah, that concludes my. So you're muted.
Sai Kamal, you are not audible.
Yeah, hello.
Yes, now you are.
Yeah. So I'm presenting solution for problem F. So in this problem, we are given two arrays A and B. A has length of n and B has a length of n. So we have the sequence A1, A2, so on up to An, and a sequence B1, B2, so on up to Bm. And we are asked to construct a matrix capital M such that the ij element of this matrix is exactly is equal to the product of the ith element from the first sequence and jth element from the second sequence. So mij is ai times ai times bj. Then so we essentially have this matrix. So a1, a1 b1, a1 b2, so on, and a2 b1. So this is the kind of matrix that we are forming here. Then we are asked to do an operation I comma j such that you make all the elements of ith row and the jth column equal to 0. So you pick ith row from here and jth column from here, take all elements of this row and put them equal to 0, and take jth column of this elements and put them equal to 0. So essentially there is an intersection uniquely, and that will also will become 0. So all elements that are in ith row or jth column are going to become equal to 0. So this is the kind of operation that we are allowed to do, and we need to do this operation exactly once for each query. And in a query they are given as a value x, and and we are asked to find if doing this one operation, if we can get the sum of all elements of this matrix equal to exactly x. So we have to do this single operation and figure out if we are able to make the sum of all elements equal to x in this. So I will present two different ways of solving this problem. The first method is like figuring out what so if we try to find what this exactly means to do this operation. So first let's figure out the sum of all elements in this matrix. So what would that be? Sigma mij. So if we see this thing is just sigma over ij, ai times bj for all I and for all j. So we can see that I terms and b terms are independent of each other. So this will just split into sigma ai times sigma bj, and this would be sigma ai times sigma bj. So then the idea is like if we represent this with capital A and represent this with capital B, we essentially have that the sum of all elements without doing any operation to be A times B. So if we try to find out what does doing this operation do, so when you do this operation, all elements of ith row are getting deleted, all elements of the jth row are getting deleted, and the element at the intersection is being deleted twice. So we will just add it back. So after doing the operation on I comma j, the new sum, which I am going to represent as Sij, would be is equal to our original sum S minus deleting the ith row, which would be, so if you remove this row, the sum of all elements in sorry, ith row and jth column. So if you remove all elements of the ith row, so its value would be ai times b1 plus b2 so on up to bm. So that is just ai times capital B. So this would be minus b times ai, and then you also remove the jth column, so it would be minus a times bj, and then you, because you have deleted the intersection twice, you would add it back, so it would be plus ai bj. So we want this value to be equal to x, so that is what we are targeting. So if we rearrange these terms a bit, or if you see x is equal to a, s can be written as a times b minus b times ai minus a times bj plus ai times bj. So this thing you can directly split as a minus ai times b minus bi, so bj. So like this equation is just the splitting of, I mean, if you just expand this polynomial, this is what you are going to get. If you expand these terms, this is what you are going to get. So but this and this is not just independent of each other, like you can evaluate this guy independently and this guy independently. So essentially if you replace your sequence of ais with sigma, like if you evaluate a and just set ai dash equal to a minus ai and bi dash is equal to b minus bi, b minus b minus bi for bi dash, or if you prefer j, then x is equal, so this can be done in o of n time and this in o of m time, and you just have x time x equal to ai dash times bj dash. So now you have this newly created sequence and you can just figure out among the factors of x. In the question, x is given that it only goes from 1 to 2 to the power of 5. So you can go over all the factors of x and figure out if there is any splitting of them into two such that this and this would satisfy. So just go over all the divisors of x and figure this out. Like we know that the number of divisors for a element x would at most be x to the power of 1 by 3. So like this would easily fit in the complexity for q queries that are given, and we are also given 4-second time limit for this problem. So this will easily fit. So just go over all the divisors of x, figure out if there is a split ai and a bj dash, and to know if this ai dash and bi dash exists, you can just maintain a set and figure out if this like keep the set of ai and keep the set of bi, then you can just do the operation in log n time to figure out if this elements exist or not. So this is one way of doing the problem. uh, so if you want to avoid sets and using these divisors factors, then there is another slight variation way in which we can do, which relies on the fact that it is given that x lies between 1 and 2 into 10 power 5 in the problem. So if we see that x lies between 1 and 2, 2 to 10 power 5, we have that s minus the term that we are subtracting equal to x. This is what our target is, like over here. So what this means is we can put s minus x equal to this target term. So what we are trying to find s minus x such that this is equal to b times ai plus a times bj plus, minus ai times bj. So this is our target. Now if you see on the left hand side, it is s minus x, and we are actually given that the magnitude of x goes between 1 and 2 into 10 power 5. So the value of s minus x could go between s minus 2 into 10 power 5 to s plus 2 into 10 power 5. So This is not a big range. This is just 4 into 10 power 5. This is the whole range that we have. So if we figure out what are all the possible values that this sequence can achieve in this range, then we are done. So we want to figure out all the possible values that this sequence will achieve in this range. And then given a query x, you just subtract x from s minus x and figure out if that exists in the sequence or not. So we make a set of this size of booleans. So we can so instead of, because we have there is only one test case, you can just make it once. 4 into 10 power size cassette, you can just make it once. So make booleans and assign all of them to false at the beginning. Now in order to evaluate what these values will go, you can rewrite this sequence as b times ai plus uh, capital A minus ai times bj. So the point is, if you fix ai, the value this becomes constant and this becomes constant. The only variable is bj. So bj is the only variable here if you fix ai. So if you iterate over all the value of ai, so go over all ai, specifically go over all the unique values of ai. This is important, otherwise you may hit TLE again. So go over all the possible unique values of AI, and let's say we are targeting this value to be alpha. So alpha is our target. So what do we have? We have that b times. So if you try to rearrange this term for specific AI, you get bj is equal to alpha minus b times AI by a minus AI. Now we want to target this value of alpha from we know what's the upper bound and lower bound of alpha, because alpha could only go from s minus 2 into 10 power 5 to s plus 2 into 10 power 5. This is the range at which alpha can go to. So you can figure out an upper bound and lower bound for bj. You get a lower bound for bj and an upper bound for bj for a specific value of, so you have a lower bound for bj and upper bound for bj for a specific value of ai. So you can just write this as, for a specific value of ai, you have an upper bound and lower bound for bj. Something like this. So for a specific value of a, there exists a lower bound and an upper bound in which bj could be there. Now you can iterate over all the elements of bj which are within this range and set the value of this whatever all the possible values of bj, and evaluate this value and set the value of this in this array to be true. Got it. So go over all the values of bj in this list, and whenever evaluate this value and set that value to be true in this set. So it, at first it might look like this is going to exploit the time complexity, but it won't if you go over unique values. So the way you can prove this is, assume like we are targeting over this delta range that we have over here. So say assume that delta is the range that we are trying to target, which is basically 4 into 10 power 5. That is what we are trying to target. So if you have b of ai plus a minus ai times bj equal to alpha, and now if you fix ai, this is a constant, this term is a constant, and this is a variable. So for this term, uh, for the range of delta values that exist, the number of possible unique values of bj would be of the order of delta by a minus ai for the specific value of bj. I mean, for a value of ai, this will be the number of possible values. So all the possible values of ai, your time complexity would be delta by a minus ai ka sigma. Now when a equal to ai, then that case you can handle separately, because this term would just vanish and b times ai is just in the set. So you can just say that b times ai is in the set. In all the other cases, this is the sigma that you have. Now you can see that this is no more than n terms here. So because you have only n values of this guy, so they are no more than n terms. So now because delta is constant, put the delta out, we have 1 by a minus a I. Now given the condition I such that ai not equal to a. And the fact that we are going over unique values of AI, we can show that this sequence would always be less than or equal to half times 1 plus 1 by 2 plus 1 by 3, so on up to plus 1 by n by 2. So the fact for this is, if you see the sequence over here, I mean, we have to actually take the magnitude because a minus ai could be negative as well. So we are actually talking about the magnitude. So what are the number of possible unique values that this is going to hit? So this sequence would at most hit n unique values. I mean, this has to exactly hit n unique value, at most n unique values, because you are going over all the unique values of AI. So there are only at most n unique values. If there are at most n unique values, uh, and which can take in the order of my negative and both negative and positive integers, these so you are trying to figure out 1 by I sigma for ai sigma for those integers that you have, and you have n of them. So in order to maximize that, take always the maximum possible element from this list. So you have your list 1 minus 1, 2 minus 2, so on. So in order to maximize this delta, you go in the decreasing order of their inverse values. So this is the decreasing order in which their inverse values are 1 minus 1, 1 by 2 minus 1 by 2, 1 by 3 minus 1 by 3. So then, so both of these have magnitude 1, both of these has magnitude 2, both of these have magnitude 3, so on. And the magnitude is going on decreasing. So in n unique possible values, in order to maximize this thing, you would pick from the uh, n by 2, all the n elements from this top, like in this order. So because this won't follow that order, this is the upper bound of this list. So the sum of these values cannot be more than this. So this would be 1 by 2 times. I mean, if you put the delta, this should be delta by 2 times. And you know that the sequence of sigma 1 by I for I from 1 to n would be of the order of log n. So this means that this would be of the order of log n by 2, or basically O of log. I mean, you can ignore those constant with respect to log n. So this would be delta by 2 log n. So the overall time complexity would be delta times log n. And delta is of the order 2 into 10 4 into 10 power 5. So this is a kind of operations that you're doing. So this is another way in which you can do the problem. So that is my solution for problem F. Now we'll discuss problem G. Let me see if you have any questions. Right. So we are going with G1. So in problem G1, you have you are given n a sequence of n numbers a1, r1, r2, so on up to rn, and then you are given that each of these candidates has a plushie with them, and in each step, uh, the ith candidate, there's a first candidate, second candidate, nth candidate. The first candidate will give at most one plushie that he currently has to the candidate r1. And in the G1 version of the problem, if a candidate gets more than one plushie at any moment of time, he will just discard the other plushie that he has. So a person would at most hold one plushie at a time. And we are asked to figure out when will this sequence stabilize if they keep switching their plushies. So the idea here is that if you see the sequence, this could be seen as a directed graph. So between node I to j, there would be a graph if there is ri equal to j. So if ri equal to j, you can represent this as a directed graph pointing from I to j. So what this means is that this guy has a plushie. Then in the next step, he would give it to the person j. So what makes this graph unique is that this graph here is has always out degree of 1. Out degree is always equal to 1 for any node, because only he will always give to only one person. So we have out degree equal to always 1. So what this means is that the structure of this graph would look something like this. So if you see person 1, he would either give to himself or give it to some other person too, and the person two again could give to person one or give it to some other person three. And this I mean, this is some sort of permutation of them, obviously. And if you go back, either this chain of loops has to end somewhere. So the only way this would end is if this guy somewhere loops back and attaches to some other element in the same path. So the way this structure would look is as if a graph of cycles connected with some sort of trees. So in this graph, you basically have loops that exist, and then there are trees attached to this loop. There could be multiple trees attached to the loop. So this is the kind of graph that you will get. So basically there are some set of, like, this is basically independent set of stuff that would exist in this graph. So all of these are independent of each other, and each of them looks like a loop and connected with some graphs, and all of these graphs would always point towards the loop. So all these nodes will always be heading their heads towards the loop, and inside the loop it would always be some sort of a cycle formed. So the idea here is that because they will at most always at most hold one plushie at once, we can assume that these loops are dead. So basically the idea is that loops are dead. So the thing that happens is, like, first person gives it to the second person and he gives it to the third person, and it just loops back and the person behind him gives to this guy. So all the plushes in the loop just get circulated among themselves, and any of the node vertex that comes from the loop will just get out, will be discarded when it just enters the loop. So now the question is, like, what is the maximum amount of time that it would take for this graph to be stabilized? So in order to evaluate that, we can see that because this is just discarding it and there is at no point they are stopping the process, whenever the last node vertex comes to this point, this tree would be dead. So all of loops are always dead, and we want all of these guys to be dead. So when would these guys would be dead? When all the vertices, all the plushes with them will get to the root. So because they are always holding at most one plushie, this would be equal to the longest possible chain that we have in this loop. So basically, for any loop, just figure out what is the longest possible chain that it is forming in the graph. So maximum possible depth of the element plus one should be your final answer, because they're asking one plus that thing. So basically the maximum depth of the tree plus one is our answer. So we have to figure out the maximum depth of the tree. So to do this, you can go, like, you can do a DFS on this thing, and whenever you hit back the element, do back tracing in order to complete the loop. And once you hit the loop back, assign the depth for each of those nodes. And whenever you hit a already visited element, you will again just DFS it back. So if you do the sequence of DFS calls, at the end of the day, all the elements in the loop will be declared as loop elements, and all the elements that are in the chain would be declared with their depth. And among all the possible depth, figure out the element with the maximum possible depth and add one and return this as the answer. That will solve your G1 problem. And G2 is just slight variation of it. Here they said that in G2, instead of just losing the plushie, they will hold the plushie, and they are asked to tell us when this sequence will stabilize. So here again, loops are still dead. There is no change in the loop. The only thing is, like, instead of discarding the elements, now they will hold the elements. So this is the kind of the variation of this problem, if you know, of let's say there is a alpha elements here, beta elements here, and at most one element can flow at once. So what is the maximum amount of time that it would take for all the elements in this graph to be removed out? So because in this graph, initially all of them have at most one element, and we can kind of think this as a flow of water or something that you would like to imagine, and you can see that there will never be any gaps in the flow. So gaps in this flow does not exist, if you think. So if gaps in the flow does not exist and there is like 1 unit of flow each second, the amount of time that it would take for all the pushes to get out, or all the water in this flow to be completed, would be exactly equal to the amount of water in the node in this graph. So the amount of water in this graph is exactly equal to the size of this graph. So the amount of time that it would take for this tree to vanish would be the size of this tree. So instead of this DFS call, now you would actually go and figure out what is the maximum size of the tree, these kind of trees that are connected. In order to do that, what you could do is like, when you're backtracing, you know what is the start element of the node. So at the start element of the node, you can keep some sort of child count variable. And when you are doing this DFS call back again, when you hit a already visited element, then you see the parent of this guy, backtrace it back and update the count and just add it there. So whenever you are backtracing and you found a visited node, you would backtrace and update this count by 1 1 each time for each of the nodes in your path. So when you do that at these nodes, which are the roots of these trees, would be stored the size of this tree. But there is one problem, but like it could be possible that these trees are from different origins as well. Like this is the loop that is connected. So instead of storing it over here, you store on this particular node that it is connected to. So basically go over these nodes and figure out what is the maximum size of this tree, and maximum size plus 1 would be your answer for this G2. So now Mihir sir would explain H.
Hello, is my screen visible?
Yes sir.
Okay, so I would be explaining problem H. So this problem did not involve any sophisticated techniques but had a lot of mathematical manipulation. So the basic statement of the problem was we are given a grid of size x into y with indexing from one row indexing from 1 to x and column indexing from 1 to y. We needed to find the sum from I equal to 1 to x of sum j equal to 1 to y of uh, x I x times I plus wait y times I plus j times grid. So if the grid is called m times m into y I plus j. So the idea was to separate the row component and the column component of the matrix. So the row component is of the form yi m yi plus j, and the column component is uh, uh, yeah, it is j times m yi plus j. Now we can observe that we can calculate this sum for a single one-dimensional array. So let's focus on row I only, row 1 only for now. So in that we needed to find the sum of m1 plus. So if we consider only the j times mj contribution, only j times myi plus j. Then we needed to find m1 plus 2 m2 plus so on up to plus I think it's yeah y my. Yeah, and similarly, if we had taken some let's say ith row, then the j times myi plus j contribution would have been m of y times uh, I minus 1 plus yeah. here it should be I going from 0 to x minus 1 plus 1 plus 2 times y times I minus 1 plus 2 plus so on up to. Similarly as for the first row. So let's find this contribution first, where we are fixing the row and we are varying the columns. So yeah, so that's what I did here. So this does the same as the above. So for the entire grid, I did this calculation. So row ij is equal to j times aij plus row ij minus 1. Because we have fixed the row index, we are just varying the column index. So this naively finds the row contribution. Okay. So if the constraints, so if we were allowed in each query to iterate on the rows as well as on the columns, then we could have just summed this, like taken some prefix sums on this row and then outputted the answer in certain manner. So like, by the way, this is not the entire thing that needs to be considered in the row contribution. So in query, the columns started from C1 and up to C2. So we needed to find, so let's say if we are focusing on a particular row, so we needed to find this sum RC1 plus 2 RC1 plus 1 plus so on up to C2 minus C1 plus 1 times RC2 minus C1 plus 1. Now this can be written as, sorry, here it would be C2. So this can be written as C2 times R of C2 plus so on up to C1 times R of C1. Sorry, C1 times the C1 times R of C1 plus so on up to 1 times C1. Uh, so 1 times R1 minus uh, yeah, minus C1 minus yeah, minus C1 minus 1 R of C1 minus 1 plus so on up to 1 times R of 1, and this is whole divided by, this is divided by uh, not divided, I'm sorry, this is not divided, and this is finally subtracted, um, so C2, mm, yeah, and this is finally subtracted with C1 minus 1 times the uh, sum of, just simply the sum of the row elements up to C1. So we are calculating terms of this form to get the row contribution for the subgrid. So that's what the row 2D row did for each of the row. And still we are not done here, because if even if we find this for each query, in order to find the entire answer, we would need to iterate on each of the row. So in order to avoid that iteration, we find some prefix array on this row vector. So I won't be able to go into detail of how this prefix row is formed from the row, but the basic idea was to find the sums for all rows at once. For each row, this sum was found in the row 2D vector, and now for a collection of rows, it is found in the pref row 2D vector. Similarly, the contribution of columns is found out by the same argument, and some coefficients need to be adjusted for columns, but the argument is entirely symmetric as that of row. And finally, after having found out pref col and pref row, we also need to check the sum of the grid. So in if we find the expression of what the entire thing would come out to be, it also needs the sum of the subgrid. So to find the sum, we can just perform a simple DP. Sum of ij is aij minus sum ij minus 1 plus sum I minus 1j plus sum ij minus 1. So basically, sum ij is the sum of all aij's, axy's, where x is in between 1 and I and y is in between 1 and j. So having found out these three 2D vectors, sum, pref row, and pref call, we finally express our row contribution as some function of these three 2D vectors and column contribution as some function of these three 2D vectors. What this expression exactly turns out to be, that depends on your implementation, but nothing more than simple mathematical manipulation would be required to find that. And finally, we just the pre-computation was O of n square because each of the for loop iterated once from 1 to n and another time again from 1 to n. So the total complexity of this problem is O of n square plus q. And one thing to note was like if you declare these arrays inside the main function or the solve function, there is a chances that you would get MLE or TLE just because allocating too much memory on the stack, uh, allocating too much memory locally, not on stack. So instead, one of the optimization that I needed to do to get an AC was make all the 2D vectors global. So that's what you can try to in case your code exceeds the time limit. And yes, that's all there was to this problem. Okay, so we would be ending the stream now. Thanks everyone.